Assalamualaikum. My name is Zahin Azhari bin Zaidino. Today our topic is electricity and I will be talking about electric flux. Electric flux is the measure of the electric field through a given surface. It is a way of describing the electric field strength at any distance from the charge causing the field. Electric flux is proportional to the number of electric field lines going through a virtual surface. For a better and clearer understanding, I will imagine electric flux is something like this. This is two metal plates, and then this is electric field lines. Uh, Electric flux happens when there is a electric when there is a force going through the electric field lines, and the angle will be proportional to the electric field lines. So when that happens, when the force cuts through the electric field lines, and that is when electric flux happens. So if the electric field is uniform, the electric flux passing through a surface of vector area S is phi E equals to E times S equals to ES cos theta, where E is the magnitude of the electric field, S is the area of the surface, and theta is the angle between the electric field lines and the normal to S. For a non-uniform electric field, the electric flux d phi E through a small surface area ds is given by d phi E equals to ds, where the electric field E multiplied by the component of area perpendicular to the field. Electric flux has SI units of voltmeter, which is Vm, or equivalently to Newton meter squared per coulomb, nm square c negative power to the power of -1. Thus, the SI base units of electric flux are kg times m to the power of 3 times s to the power of -3 and times ampere to the power of -1.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Aswad Uwais Qorni bin Zaman. My metric number is 190644. Alright, for today, my group will present about electric flux. So my part is the content. So we have two content, which is Gauss law and the application. Alright, for the Gauss law, we know that the Gauss law means the total of electric flux out of a closed surface is equal to the charge enclosed divided by the permittivity. Okay, what does that mean? Okay, it means that the electric flux within an area is determined as the electric field multiplied by the area of the surface projected in a plane is perpendicular to the field. So we know that whatever the surface is, okay, so the electric flux within an area determined when the electric field multiplied by the area surface must be perpendicular to the field. Okay, perpendicular means 90 degree. Alright, so Gauss's law is a universal law where it's implemented any closed surface. Okay, so I give an example. If we have a cone, but the cone, the lower side of the cone is not closed, which is it's open surface, so we cannot apply Gauss's law. Right, so it's an important tool since permits the assessment of the amount of enclosed charge by mapping the field on the surface outside the charge distribution. Okay, this one means that the Gauss law means that the surface, the charge by mapping the field, the charge it's outside the surface. Okay, it's outside the surface. For geometries of sufficient symmetry, it simplifies the calculation of the electric field. Alright, so in another way of visualizing this is to consider a probe. Okay, a probe, we have a probe, and then the area of the probe is the surface of the probe. Okay, so how do we estimate the electric field? Is the electric field must be perpendicular to the surface, which is if the probe is like this, the surface must be the electric field must be perpendicular. If the surface we choose like this, so it must be like this. If we choose here, so it must be like this. It's perpendicular. Alright, so if it picks any closed surface and steps over that surface, measuring the perpendicular field times its areas, the perpendicular field must times the areas, then we will obtain the measure of the net electric charge within the surface, no matter how that internal charge is configured. Alright, for my second part is the application. So we have the conducting cylinder, which is the conducting cylinder. Okay, the electric field of an infinite cylindrical conductor with a consistent linear charge density can be achieved by using Gauss law. How do we achieve that? So regarding a Gaussian surface, the Gaussian surface is the surface within the cylindrical conductor in the form cylinder that okay, so we must have a radius small r must be greater than capital R. Alright, so it means that the electric field has the same magnitude at each point of the cylindrical and is pointing outward. Means on the surface of the cylindrical conductor we have only positive charge along the surface. Okay, so what means by the pointing outward? It means that when it's pointed outward, so it's perpendicular to the surface, whereby the electric flux is then just the electric field times the area of the cylinder.
Alright, so I'll be explaining a couple of examples regarding electric flux. So for the first example is a constant electric field of magnitude E node points in the direction of positive z-axis, which is upwards. So you can see that in figure 2.1.7. So what is the electric flux through a rectangle with sides A and B in the A xy plane, which is the bottom plane, and B xz plane, which is the left plane for me right now. So how do we tackle this question? Is really simple. There are no values whatsoever, so you'll just answer it in unknowns. So in this case, for A, phi is equals to E node A, and A is the product of A and B, so thus the answer is E node AB. So why do we not consider the cos theta? This is because the points, E node points, is along the normal line, so thus the angle is 0. Cos 0 is equals to 1, so we don't need to consider that. So for B, we can see that right now the E node points are along the the surface, exact surface. So because it is along, so it is cos 90, and cos 90 is equals to 0, so therefore it has 0 flux. For the second example, a cylindrical metal can has a height of 27 cm and a radius of 11 cm. The electric field is directed outwards along the entire surface of the can, including the top and bottom, with a uniform magnitude of 4.0 exponent 5 Newton per coulomb. So, how much charge does the can contain? Alright, so this might seem like a confusing question, but no, actually. So as we know, phi E is equals to EA, so we need to find the area of the entire can. So the area of the sides of the can is 2 pi RH, and the top is pi r squared. We can simply just calculate everything, so we'll get a total surface area of 0.2626 meter squared. So we can figure out the total flux of the can. So we have the E, which is 4 exponent 5, and we have the the total surface area, which is 0.2626 meter squared. So that will yield us a total flux of 1.0504 exponent 4 Newton meter squared per coulomb. So that is the total flux out of the can. If we look by Gauss's law, the charge inside, which is always the constant of positive 9.3 exponent negative 7 coulomb. So that's it for this question. It's relatively easy actually.
As a conclusion, electric flux is a property of an electric field that may be thought of as the number of electric field lines that intersect a given area. Electric field lines are considered to originate on positive electric charges and to terminate on negative charges. If there is no net charge within a closed surface, every field line directed into the surface continues through the interior and is directed outward elsewhere on the surface. The negative flux just equals in magnitude the positive flux, so that the net or total electric flux is 0. Electric flux is very important in our daily life, it is it plays an important role in electricity in producing electric force. That's all from me. Thank you.
Alright, so I'll explain about the some Islamization about the topic of electric flux. So, electric flux is a type of force that we cannot see directly. So, it falls under the category in Islam we call al-ghaib, which is the unseen forces. So, regarding the unseen forces, al-ghaib, we should believe in al-ghaib in any ways possible, because in Islam there are lots of things that we cannot see, and we can only know them by revelation and also research. So mostly things al-ghaib that we can know by revelation is the angels, shaitan, jinn. We can't see any of these. But so the other one is al-ghaib that we can research to see. So these are things like atoms, particles, forces, such as electric flux. So we should believe in al-ghaib in any ways possible. And uh, actually, Allah is the knower of al-ghaib. He knows everything about it, and it's very easy for him to see, compared to us humans who can't see it at all. And sometimes we can see it, but with the aid of what we call special equipment. So it states here in Surah Zumar, Surah number 39, verse number 46. A'udzubillahi minasyaitanir rajim. Qulillahumma fatirus samawati wal ardi alimul ghaibi wasyahada anta tahkumu baina ibadika fima kanu fihi yakhtalifun. So the meaning is Sahih International. Say, O Allah, creator of the heavens and the earth, knower of the unseen and the witnessed, you will judge between your servants concerning that over which they used to differ. So alimul ghaib, knower of the unseen. So here it clearly shows that Allah knows everything about al-ghaib. Compared to us, we don't know a thing. So that is one of the things that we can relate from electric flux and Islam itself.